Okay, so we're going to work on factoring polynomials today. And we're going to start on this page. Make sure you have something to write with and open your notes to this page. So, we're going to put an example up here. We're going to start with 2x squared minus 5x minus 12. So this is a polynomial, more specifically a trinomial. You should be familiar with this. We've done math with these. We have added, subtracted, multiplied, and divided with them. But what we're going to do today is factoring. And so this is going to be your problem, and it's going to say to factor it. And then you're going to do some work, and you're going to get this as an answer. So x minus 4 times 2x plus 3. What you should notice is that going from here to here, you have done before. You have taken two binomials and you have multiplied in order to come up with that trinomial. That's our multiplying. So you've done this before. What we're going to do today is we're going to undo that multiplying. So going from here to here is what we call factoring. So if you were going to put this into a real world example, when we did multiplying polynomials, this would have been your length and your width. And you would have multiplied them to come up with this trinomial, which would have been your area. What we're going to look at now is you're going to be given the area. And from the area, you're going to come up with your two factors, which would then be your length and your width. So that's the kind of stuff we're looking at today. We're going to undo our multiplying. Okay, so on these notes, we're going to kind of skip around. We're going to do the first box number 1 today. So if you will kind of come down here, box number 1 is going to be your greatest common monomial. So if you remember when you were younger, you did greatest common factors. This is going to be very similar. You're going to read this, and it says if every term in the problem has a common factor, a GCF, a greatest common factor, or GCM, greatest common monomial, you're going to factor it out. And you might want to underline this or highlight it if you have a highlighter near you. This includes a negative if the leading term is negative. So that means if your first term, when it's in the correct order, your leading term is a negative, that has to be factored out as well. You've kind of done this before. This is undistributing. So we're just going to do what you did with distributing, and we're going to undo it. We're going to take that value out. So we're going to do two examples in this box. The first example is 24x cubed plus 2x squared minus 8x. So on this, we have to look at it. Before we can do anything else, my first step, and you are in box number 1, which is step 1, is to look at this and go, is there anything that all of these terms have in common? Can I factor something out of it to undistribute to make it a little simpler? And you can look at it. They're all even numbers. So I could factor out a 2. They all have an x, so I can also factor out an x. So I'm going to factor out a 2x. And then I'm going to rewrite the rest of my polynomial with parentheses because this still is part of my problem. It would have to be multiplied back in to get to the original. So if I was to factor out or divide a 2x out of 24x cubed, it would leave me with 12x squared. If I took a 2x out of 2x squared, it would just leave me with an x. And if I took the 2x out of the negative 8x, it would leave me with a minus 4 or a negative 4. And if you were to work backwards, so from here up to here, 2x times 12x squared is 24x cubed. 2x times x is 2x squared. And 2x times negative 4 is negative 8x. So you undistribute it. This guy right here, this 2x, this is your GCM, your greatest common monomial. So you have factored out. Now it doesn't go anywhere, it has to stay right there. But this would be your first step on any factoring problem. You're going to look at it and go, is there anything I can factor out? Does it have a greatest common monomial? So we're going to do one more in that box. This one is a little shorter, negative 4x plus 8. And on this one, I can look at it as well and go, what do these terms have in common? Well, they're both divisible by 2, but that's not going to get me as simplified as I want. I can look at it and go, well, 4 will go into both of them. But I have to pay attention to this right here. My leading term is negative, so I want to factor out a negative 4. So negative 4 times what gets me negative 4x? It's just x. And negative 4 times what gets me 8? It's my negative 2. And then this right here, my negative 4, that is my GCM, my greatest common monomial. Factoring out the negative is one you guys tend to forget frequently. So be careful with that. You have to factor that negative out of there. Okay, we are going to skip step number 2, or box number 2. We're going to go to the next page, and we're actually going to skip box number 3. We're going to go to box number 4. So, we're going to kind of come back and fill these other ones in as we go, but we're going to start with box 4. So box 4 is going to be 3 terms. And it's going to look like this: ax squared plus bx plus c. Now your a, b, and c will all become numbers. So for example, 2x squared. But it's going to be in this format. Now, your process is written right here. First thing you're going to do is box number 1, is factor anything out that they have in common. Then you're going to go through this process here, and it is beautiful and it works. So let's go through an example. 3x squared plus 14x minus 5. When you are doing this, the a, b, and c are your coefficients. So the 3 is a, 14 is b, and the c is negative 5. So I look at this and I go, do these 3 terms have anything in common? Is there anything I can do with box number 1, factor something out? And the answer is no. So then I'm going to go through this process here. The first thing says I'm going to multiply a and c, and I'm going to list its factors out. So over here I'm going to do 3 times negative 5, and that is negative 15. And then I'm going to list all the factor pairs of negative 15. And when we do this, we're going to kind of ignore the negative sign for a minute. We're just going to list the factors of 15. If you do this in an organized manner, starting with 1, it makes it a little bit easier. So we have 1 and 15. 2 doesn't work. 3 and 5. And those are the only ones. Some numbers are going to have a whole list of factors. Some are going to have a short factor list. It just kind of depends on the value. So now it says I'm going to pick factors that are going to combine to give me the b value. So I need 2 numbers from this list, a pair, that are going to, if I was adding like terms, going to give me 14. Now what happens is none of these are going to give me 14, but this is a negative 15. So 1 times 15 does not give me negative 15. 3 times 5 does not give me negative 15. One of these numbers is going to have to be negative. So if I was to do 3 and 5, if I had a negative 3 plus a 5, that's a 2. Vice versa would give me a negative 2. So I'm going to look at this set. It's going to be this one right here. But I have to figure out which one of these becomes the negative. Is it going to be a negative 1 and a positive 15, or a negative 15 and a positive 1? So if I want to combine to make positive 14, I'm going to want this one to be negative. And I can check my math. Negative 1 times 15 is negative 15. Negative 1 plus 15 is 14. So what I do is I come in and I rewrite this, 3x squared, but instead of 14x, I'm going to split that into these 2 terms, negative 1x plus 15x, and then I'm going to continue with my minus 5. Now the question is, did I really change the value from here to here? Is negative 1x plus 15x still 14x? Yes. So my problem hasn't changed in value. Now that I have my four terms, I'm going to group them. So I'm going to put parentheses around the first two, and I'm going to put parentheses around the second two. Because addition and subtraction are commutative, it's okay, I can do that. Now I look at the first set of parentheses, and I say, kind of going back to door one, what does that set of parentheses have in common? What do those two terms have in common? And it's an x. So I factor out an x, and that would leave me 3x squared divided by x is just 3x. Negative 1x divided by x would just be negative 1. All I did was undistribute or factor out an x. This right here still has the same value as this right here. Now I look at the second set, that second binomial, and I go, what do these two terms have in common? Well, they both have a 5. And it's a positive 5, so I'm going to put a plus 5 in a parentheses. And if I was to distribute that back in, I would have a 3x minus 1. 5 times 3x is 15x. 5 times negative 1 is negative 5. And again, I didn't change the value because all I did was undistribute or factor out that 5. This right here, if I was to multiply, would still get me back up to here. Now I look at this and I say, well, here's one thing being added to another thing. Well, what do those two things have in common? They both have a 3x minus 1. So I can factor a 3x minus 1 away from both of those. And if I do, that 3x minus 1 still has to be multiplied by x, and that 3x minus 1 still has to be multiplied by 5. So those two things come down here and they make your second binomial, and then you're done. And again, I didn't change the value from here to here. I factored that out. I'm still going to multiply 3x minus 1 by x to get this. And I'm still going to multiply 3x minus 1 by 5 to get this one. Then that's your factors. You have 3x minus 1 times x plus 5. You can go back and check this. You can multiply your two binomials, and that would get you all the way back to your trinomial. Okay, that's all we're going to do today in the notes. We will continue in class.